Hello. Good morning, everyone. Today we are going to be learning lesson 12.3, day 3, the last lesson in 12.3. We're going to be wrapping up the lesson today, and that will be involving with solving real-world problems involving finite geometric series. So we're going to take a look at how this is used in the real world. Example 1. Deanna received an email asking her to forward it to 10 other people. Assuming that no one breaks the chain and that there are no duplicate recipients, how many emails will have been sent after 8 generations? So this is one of those email chains, right? So we need to understand that Diana's email is the first one that gets sent, but she will send it to 10 people, and then those 10 people will send it to 10 people. So the next round, we will have 100 people that have received it. And then the next round, we'll have 1,000, so on and so forth. So when it gets to 8 generations, so this will be 10 to the first, 10 to the second. So at the 8th generation, it's going to be hitting 10 to the 8th power. And so from here, we can actually derive what our A, N, and R equals to. Well, the first value is going to be 10. That's the first number. And then number of generation is 8. So N is equal to 8. And then ratio should be 10 because you are multiplying 10 to get to the next number. So the ratio is 10. So using the summation formula that we just learned in the previous lesson, that we're going to use S of n is equal to A times 1 minus r to the n over 1 minus r for our formula to add this sequence. We're going to substitute A, which is 10. 1 minus the ratio is 10 again. Generation is 8 over 1 minus 10. And you can use a calculator to do all this math. It should work out to be 111 111 and 110. So how do I even say this? 111,111,110. So double check to make sure that that's the number you're getting. And then at the end, it says how many emails will have been sent, including Deanna's email. So then we got to add the one that Deanna sent. So this is D right here. Okay, Deanna. Okay, and we're going to add that one, so we will get a total of 111,111,111 emails altogether. And that is the answer for this problem. Example 2. Miguel paid $9,600 in rent for his apartment for the first year. Every year for the next 3 years, the rent increased by 5%. So how much rent did he pay in the 4th year? So if you actually take a look at the rent that Miguel pays, in the first year he pays $9,600. The next year, to increase that by 5%, you're actually going to be multiplying by 1.05, because if you're just multiplying by 0.05, it's only equivalent to the increase. It does not include the base, which means the 9,600. So it's actually multiplying by 1.05. And so the next year, he should be paying $10,080. And then after that, another 5% increase should be $10,584. And then after that should be 11,113.20. So those are the first 4 years. So here is A's of 1, A's of 2, A's of 3, and A's of 4. So this is the 4th year that he will be paying, and that is the answer for the first question, part A. Part B says, and that's dollar amount. How much rent did he pay altogether in 4 years? Well, we can actually probably get the answer a lot faster if we just end up adding all of these together. But just to make use of the formula that we have, you can look for S of 4, which is the initial value, 9600, times 1 minus the ratio, which is 1.05 to the fourth power, over 1 minus 1.05. And so you should be able to get a total of 41,377.20 cents for the total. Or, like I said, you could also get the same answer by adding all these numbers on top together. They should be exactly the same. And that's the end of this problem. Example 3. This is number 14 on page 507. A ball is dropped from an initial height and allowed to bounce repeatedly. On the first bounce, one up and one down motion, the ball reaches a height of 32 inches. On each successive bounce, the ball reaches 75% of its previous height. What is the total vertical distance that the ball travels in 10 bounces? Do not include the initial height from which the ball is dropped. So I'm just going to kind of draw a figure of what this represents. So here's the ball being bounced. We do not know how much it was dropped right here. That's what it says. We don't know. But after that, whatever is dropped, it's coming back. So it's 32 here. But then we're going to, so once it will reach the top, it's going to drop, reduce by 75%. And then it needs to come down this 32, the same height that it come before it comes back up to the next height. So it keeps getting less and less. So here's kind of like the motion of the ball. So the initial value is equal to 32 plus 32, which is 64. So we're counting from the generation from here. And then it says do not include this first step. So whatever it is, we don't include it, but we include the first repeating one. So if we count the first one coming up 32, going down 32, that's 64. And then that will be 64 for the first one. And then it'll be next round, 75% of 64, whatever that is. So the next round, it's going to come back up. It's only going to be 48. Then after that, it's going to be 36 and so on and so forth. So it wants to know when it gets to the 10th round. So the three values that we were looking at is A, N, and R. So N is going to be 10 because we want to know at the 10th round, 10th bounce, what is the height going to be travel total, right? And then ratio is going to be, it is being reduced. So it's less than 100%. So it's only coming back 75%. So it's 0.75. So if we use the formula for the sum, S of 10, it's going to be initial value, which is 64, times 1 minus the ratio of 0.75 to the 10th power over 1 minus 0.75. Do the math all together. You should have the total height traveled is 241.6 inches. Or if you want to convert that to feet divided by 12, you should have 20.1 feet that is traveled in the 10 bounces. So that is the end of this problem. And it looks like it is the end of the lesson. So you may go ahead and get started with your assignment. Have a nice day. I will see you next time.